Welcome. This lesson is about just solving for all the missing parts of a right triangle. So in other words, we need to find this side length, and this angle measure because the other three things are given. We know the hypotenuse's length, we know this angle 60, and we know it's a right triangle. The angle's the easiest. Obviously, this is a 30-60 right triangle. We just minus 60 from 90 to find this missing angle here. So down here, we can type in 30 for the angle. Then I recommend you have these two special right triangles written down, and I've written it with degrees inside and with radians in red. So in case they give you the triangle in radian mode, pi force is the same as 45. And basically what we can do is we can use these simple ratios of the sides of the special right triangles to find our other sides. So since this is a 30-60, the shortest side that's next to the 60 or across from the 30 is half the length of the hypotenuse. That means the length of FG is 9. So FG is 9. And then we know to multiply that by the square root of 3 to find the longer side FE. And it says write your answer in simplified rationalized form. So they don't want you to write it as a decimal. They want you to write it as 9 square roots of 3. Again, this one was 9, this one was 30, and we've solved our right triangle. I would recommend writing these two special right triangles down because you'll be referring to them quite a lot. Okay, same thing here. This is a 30 degree, so the angle is 60 degrees. Since they give us the hypotenuse, the shortest side, JH, is half that length, or HJ will be 7, and the hypotenuse will be 7 square roots of 3. Now, eventually we're going to get to, well, here's a 45. Let's do a 45 very quickly. Since this is 45, angle T is also 45. The two shorter sides are 1 compared to the square root of 2. So I divide by the square root of 2 going backwards. So they're all going to be 8. 8 and 8 are both the side lengths because it's a isosceles triangle. I'm going to jump ahead because eventually they're going to get to some that don't have nice angles, and then you have to use your calculator, obviously. Here I just noticed that this shorter side is the square root of 3 less divided by. So this is a 30-60 right triangle. If you're unsure, you can always do the inverse tangent of one of these sides over the other to either find angle R or angle Q. But just to let you know, I mean, look, I divide by square root of 3, I get 42. I double 42, I'll find that the longest side is 84. And obviously my angle R is 30 and my angle Q is, or sorry, my angle R is 60 and my angle Q is 30, just because I have those special right triangles memorized to the point where I can just see it. But now eventually we're going to get to this type of a triangle. That's not a special 30-60 right triangle. So we're going to have to solve it a little bit differently. What we're going to do is I'm going to first solve for this side here, UV. I'm going to solve, well, actually, let's do the angle first. The angle's easy, just minus 35 from 90 because these two must add up to 90. 90 minus 35 tells me that this angle measure here is going to be 55. 55 plus 35 is 90. Now I'm going to use my trig functions to find the missing side length UV. I'm going to do that by taking the sine of 35, and that's going to equal the ratio of whatever the length of UV is divided by the hypotenuse, 7. So I'm just going to take my calculator and take 7 and times it by the sine of 35. And that will give me my length UV. So I grab my calculator. It's in my hand now. I'm going to do 7 times the, got to turn my calculator on, 7 times the sine of 35 degrees. I'm in degree mode, just making sure. And I find out my side length is 4.01. It says round to the nearest tenth. 4.01 would round to 4. Now I can either use Pythagorean's theorem or I can use the cosine. I like the cosine. I think it's easier than trying to do Pythagorean's theorem. I'm going to do the cosine of 35 because that's going to equal the adjacent side, which is TU over the hypotenuse 7. So just 7 times the cosine of 35 will give me my length TU. So on my calculator, 7 times the cosine of 35 gives me 5.73. Since it says round to the nearest tenth, 5.73 rounds to 5.7. And I have my triangle solved. Now, this isn't too bad when they always give me one of the angles. Eventually, they're going to give you one where they don't have any angles. They only have 2 side lengths. Then what we're going to do is do the inverse sine and cosine, like this one here. Let's do this one. I don't know either of the acute angles. So the first thing I'm going to do is I'm going to find angle D. The way I'm going to do it is I know that the tangent of D, whatever angle D is going to equal the opposite side, which is this side here, opposite, divided by the adjacent side, this is the adjacent to D, of 4.9. So now how do I find the angle D? D, that's supposed to be a D, is equal to the inverse tangent. Now hopefully you remember how to do the inverse tangent on your calculator of 8 divided by 4.9. So I grab my calculator, do the shift or second key cosine with the little -1 above it of 8 divided by 4.9 in parentheses, and I find out I did something wrong. Oh, I did the inverse cosine. That's the inverse tangent of 8 divided by 4.9, and I get 58.51. It says round to the nearest tenth, so the measure of angle D is 58.5. 58.5. Now I can easily find the measure of angle E by minusing that from 90, and I get 31.5. So my angle E is 31.5. Now I can either use Pythagorean's theorem or I can use one of the other trig functions to find the hypotenuse. I'm going to use Pythagorean's theorem. 8 squared, 64, plus 4.9 squared, well, I don't know what that is. I'm doing that in my calculator. But total, it's 88.01. I square root that 88.01, and I get 9.38. If I'm rounding to the nearest tenth, it is 9.4. So I use Pythagorean's theorem to find the hypotenuse. If you have any questions, please do bring them to class, but hopefully this is pretty straightforward.